All right. Are we ready to play?
Yeah.
What we're going to do, in an organized fashion, I'm going to hang up here, and you guys are going to come around this way in a single line. And what we're going to do is pack these balloons up. Put it in there. Now that wasn't too great, but when you watch the rest of us do it, now go around this way and get back to your spot. Throw it in there. In. In. And in. And in. Now this thing's full. We're not full yet. Did you hear any of them pop yet? What we're doing is, you notice all this coming off? That's because the liquid nitrogen in here is slowly boiling away as we keep adding our warm balloons with their kinetic energy molecules inside. Hey, I like that one. It's about a 2-liter capacity. Alright, so a liter is 3.8 liters in a gallon. So it's about half a gallon. Because it has pretty thick walls, right? So it has thick walls because it's basically a thermostat. Just to keep it from losing, or gaining, I should say in this case, heat too fast. So, yeah, so here's the fun part. Other than, I'll give you a don't try this at home. You want to ever win a burping contest? Train, don't start with that. Alright, are we ready? Now, we've got nearly 90 balloons neatly packed, ready for shipment. But we're not going to leave it there. I'm going to go fishing here, and we're going to see, I'm going to clear the table here first. And we're going to see what the results of this are. And then I'm going to do a quick demo for fun after that, because we'll still have some time. Are you ready? Don't try this at home either. The good news is water has a very high heat capacity, and so the moisture in my hands protects me from touching the liquid nitrogen if I touch it in a short period of time. If I stick my hand in here and hold it in there for a while and then hit it on the counter, it'll probably shatter into a million pieces. And that would be bad. Alright, it's the whole be bad thing. Alright, so let's see what we get here. Dig deeper in the well. Down the pant leg. But wait, there's more. I think you got them all. So like if you got a job being a clown, and you got like a clown car, and then you have to bring like balloons to a wedding or a kid's birthday party, bar mitzvah, or whatever the heck you want to do. Just need a couple liter thermos liquid nitrogen. You can bring enough balloons for all the kids, already blown up, and I think they would probably enjoy it. What happened to, you know what the one balloon that popped was?
Drawn on compromising the integrity of the list tag.
Quite possibly, plus it was probably blown up a little bit bigger than all the rest of them.
There's another one was drawn on that one.
Yeah, so I'm thinking more than likely, yeah, this guy, he's kind of cute. More than likely it was just blown up a little too far, and so it expanded. Yeah, because part of it was still frozen. So let me show you something. I'm going to take this balloon and I'm going to show you something else. We're going to refreeze it, and then we're going to pop it open real quick. and you two are going to be my observers. Can't take that show on the road, so I might do another one for the camera. Ooh, that's cool. All right. So cold. See that? See these? See that?
Yeah.
Watch them. Did they turn to a liquid? Not liquid. Where is it? Is it wet? Yes. So what was it? Why? I'm going to do another one for the camera here. Maybe you can see it.
Right there.
What was it? They were little white dots, right? And they just like looked like they were almost fizzing, didn't they? And then they were gone. The key to this, by the way, the key to this observation is to remember what's in the balloon. Ooh. See that?
Oh, they just went.
Did you see that?
Yeah. It's carbon dioxide. Road, isn't it? Or dry ice.
Like?
Where is dry ice?
Yeah. Where'd that come from?
Us.
You are the producer, aren't you? So, that was cool.
We see it again?
Yeah. We'll do it again. Yes, I believe. Dang, that's cold. All right. Are you ready? Gonna do it there again. Bye, buddy. Hope to find your dad. And gone. It is directly going from a solid to a gas because carbon dioxide is not stable as a liquid at atmospheric pressures. So, that happens to be also one of the prime ingredients to fire extinguishers. Fire extinguishers contain compressed liquid carbon dioxide in a cylinder because it is a liquid at much higher pressures. But as soon as it's released out of that cylinder, it actually comes out in a snow of carbon dioxide that's frozen. So as soon as it's released into the atmosphere, it turns into a solid. So that's why it blows. You see a carbon dioxide fire extinguisher, it blows this huge cloud of stuff. Okay? And it freezes and extinguishes the fire because carbon dioxide is also much heavier than air. So even as a gas, it coats and smothers out the fire because when oxygen is eliminated from a fuel source, it no longer combusts, generally speaking. There are some very rare exceptions to that. But generally speaking, that's the case.